Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about the basics of ESD. What is ESD? What is IEC 61000-4-2 standard? Okay, that and what is ESD design technique? What is ESD design technique? That means how will you take care ESD issue in the circuit design? How will you take care ESD issue in the PCB design? And what is the ESD troubleshooting skill? So these all things we are going to understand about today, right? So in the last video we have understood about the basics of EMC. Okay, so the title was EMC overview. So if you haven't watched that video, please go and watch the video. The video link is given in the I button, right? So let us understand today what is ESD, how it will impact your system. Okay, what is the causes of your ESD, what is the coupling mode of ESD. Okay, what is the rise time of ESD, what is the pulse width of ESD, and how your ESD can damage or can can damage your system, right? So these all things we are going to understand in details today. Okay, so I will request you, please watch this video till end, and I'm pretty sure you will end up learning something, right? Your time will not go in van, right? So let us understand first what is ESD. ESD is a abrupt release of charges from one object to another object. So because of that, such a discharge can permanently damage or upset the function of sensitive electronic circuit, right? So all electrical IT medical equipment are tested for ESD immunity to ensure their continued reliable operation if subjected to realistic level of ESD after being placed in the services. Okay, so you can see this is the ESD sign, ESD protected area. So this is the ESD sign, and let us say this man is doing some testing on his printed circuit board PCB board, and you can see uh, he had he had wear a one wristwatch, uh, one wristband, which ensured the ESD protection. So one end of this wristband is connected with his hand, and other end is connected with the earth. So that is how you can ensure your floor with ESD protection, right? If you don't wear this wristband, your some IC, some components or some board may get damaged due to ESD, right? So let us move ahead. So ESD is applicable to all electrical and electronic appliances. The cause of ESD is human interaction. The coupling mode of ESD is air discharge and contact discharge. And let us now understand what is the specification of ESD. So in ESD there is energy storage capacitance. The value for energy storage capacitance is 150 PF. Discharge resistance value is 330 ohm. The rise time of ESD is 0.7 to 1 nanosecond. The pulse width is 30 nanosecond, and the test voltage is for air discharge it's plus minus 15 kV, and for contact discharge it's plus minus 8 kV, right? So what is the definition of ESD as per IEC 61000-4-2 standard, right? This standard is applicable almost all the products. Okay, you can define the different voltage level. So what is the definition of ESD as per IEC standard? So it says that the transfer of electric charges between body of different electrostatic potential in proximity through direct contact. And if you look at the test level of ESD, for level 1 the test voltage is 2 kV, right, for the contact discharge here, and for the level 1 air discharge the test voltage is 2 kV. And likewise you can see for level 4 the test voltage is plus minus 8 kV, and for air discharge for level 4 the test voltage is plus minus 15 kV. So you can see here mostly we do, let's talk about the consumer product. We do level 4, that means we passed our product for plus minus 8 kV and plus minus 15 kV. Okay, we achieve this level 4. Okay, so what IEC standard says, contact discharge is the preferred method, test method. Air discharge shall be used where contact discharge cannot be applied. Voltage for each test method is given this table. So what does this standard says? The preferred method is this contact discharge. Wherever you cannot apply your contact discharge, you can go with the air discharge, because the contact discharge is more severe than the air discharge. Okay, so let us understand there is a two type of ESD discharge. One is direct discharge, other one is indirect discharge. In the direct discharge, the first one is the contact discharge. So you can see here this man is doing some twisting, and it is discharging the ESD directly on your product, on the product, right? So a method of testing where the electrode of test generator is held in the contact with EUT or coupling plane and discharge actuated by discharging switch within the generator. You can see your test generator, ESD generator tip is directly in contact with your EUT. So that is called your contact discharge F. So in this condition, your appliance should be in active mode, and you should apply 10 pulse for each polarity for 1 second in the interval of 1 second. That is 10 pulse for positive and 10 pulse for negative. Here you can see the contact discharge operation, uh, like block representation. Here we have 150 p of capacitor and 330 ohm resistance, and then it discharge through discharge electrode to your product, right? It's in direct contact with your product, right? So what is this is the contact discharge, and what is air discharge? Air discharge, you can see here better from here. You have some distance between your air discharge tip and your product. Uh, so how much this distance should be? So it's not defined in this standard how much this distance should be, but you can place your ESD gun as close as your product. Okay, it shouldn't touch, but you can place your ESD gun as close as possible. Okay, it's also a method of testing in which charge electrode of the test generator is moved towards EUT until it touches the EUT, and you can apply plus minus 10 pulse for both positive and negative polarity. So I spoke about the direct discharge. In direct discharge, we have contact discharge and we have air discharge. Now I will talk about the indirect discharge. Indirect discharge, that means application or discharge to the coupling cane in the vicinity of your. So you will have some coupling plane, that is horizontal coupling plane, and I will show you in the next slide, and the vertical coupling plane. And if this is the basic setup for your ESD, and you can see here 470 clay bleeder register is also connected to the ground reference plane. You can see here this is the 470K, and that is connected with this bleeder register is connected with the your ground reference plane here. That is GRP. Okay, that is GRP. This is vertical coupling plane VCP, and you can see somewhere is HCP also. This is the horizontal coupling plane, and they have given the dimension for the vertical coupling plane, horizontal coupling plane. So in direct discharge, okay, so you can see this is horizontal coupling plane discharge. You can see you have your product here. This is your product, this is your horizontal coupling plane, and this is your vertical coupling plane, and the man is discharging the ESD pulse in the horizontal coupling plane plane with 10 pulse for both positive and negative in the interval of 10 1 second, right? And this is the vertical coupling plane, and you can see a man is discharging the ESD pulse in the vertical coupling plane, and it is also for 10 plus minus 10 uh, 10 pulse for positive and 10 pulse for negative, and in the interval of 1 second, right? You can see different types of ESD generator. Okay, this is one type of ESD generator, this is other type of ESD generator, and you can, this is ESD generator. You can also see ESD gun tip, this is contact tip. You can see in the contact tip it is bit sharper, but in the air discharge, in the contact discharge, the tip is bit sharper. In the air discharge, the tip is a bit wider. So if you're going to do contact discharge test, you may use this tip. If you're going to do air discharge test, you may use this tip. So make sure to replace the test, replace the tip as per your test requirement, right? Let us move ahead. So the how many types of ESD, like how, what is the causes of ESD and how ESD is being generated in the system. So basically there is a three model, that is HBM, human body model, machine model, and CDM is charge device model, right? So you can see here different comparison of HBM, and CDM. Let's say for the test level, in HBM it's up to 8 kV and 15 kV, in it's up to 200 volt, and CDM it's 1000 volts. So you can also see the peak current, you can also see the pulse width, you can also see the rise time, and you can also see the failure mode in different HBM, and CDM. So I will talk about more about the HBM, human machine model, okay, in the next slide, right? So you can see the human body model, okay, human body model HBM for ESD. You can see the capacitance for human body model is 50 PF. So by hand it can generate 50 PF. By individual hand it can generate 50 PF. By individual foot it can generate 50 PF. Okay, so the absolute capacitance for human body is 50 PF. Okay, so because of the proximity of other object, in addition to the absolute capacitance, and additional capacitance must be taken in account when determining the total capacitance of the ESD. Okay, so because of the presence of adjacent object, an additional capacitance 15 to 100 PF may also exist. Okay. So apart from this absolute capacitance, you can have also 15 to 100 PF. So if you go and look at the specification, it says that the capacitance for ESD is 150 PF. So let us say for human body model 50 PF is absolute capacitance and 100 PF is let's say adjacent capacitance, right guys? So hope you are trying to understand something about ESD. Now let us move ahead in the human body model, and you can see this is the capacitor and this is the ESD gun internal diagram. Okay, it has R and C, RC cartridge. You can see RC cartridge, and for different value of resistance and capacitance for different combination, you have different cartridge. So based on your requirement, you can replace the cartridge and change the resistance value, right. So now let us move and understand the internal block diagram for ESD. You can see here this is a high voltage supply, this is charge switch RC, this is CS and CD, okay, this is RD, and this is discharge switch, and this is discharge tip. So basically we see this switch, right, while we press the ESD gun. So charging resistance is RC, energy storage capacitor is CS, distributed capacitance is CD, and discharge resistance is RD. So basically Basically, it has CS and it has CD, right? So this is ESD pulse diagram or waveform. You can see the rise time of this ESD is less than 1 nanosecond, okay, and the pulse width you can see here, it's around 60 nanosecond, right? Now let us move ahead about the USD design techniques. Okay, so how will you identify the USD test point? So USD test point identification. So any point where you have excess or the frequent access, it may get impacted by the USD. Okay, so the points on the metallic section of the cabinets which are electrically isolated from the ground, any points in the control keyboard area, any points on appliances communication such as switches, knob, buttons, indicator, LED slot, grills, connector, hoods, etc. So what is evaluation and test result of ESD? So ESD normal performance within the specified limit, temporarily degradation or loss of the function or performance which is self-recoverable, temporarily degradation or loss of function or performance which needs to be operator intervention or system reset, degradation or loss of function of performance which is not recoverable due to damage to the component software or loss of data, right? So how will you now the system level ESD design technique? Let us understand the system level ESD design technique. How will you take care your ESD in the circuit design? Okay, so consideration in the schematic design, you can use ESD or TVS diode. So since this is RS485 and its communication line, you can use bidirectional TVS diode on the signal line, right? Another tips is you can use series termination may also help in the ESD protection. You can say this is your transmitter, this is your receptor, and this is the transmission line, and you can use RS series termination to protect. It may help at some extent. Okay, you can also use the low value capacitance EG1 1 peak of 150 picofarad your signal line, that is decoupling capacitor, it will also help you in ESD. Okay, so how will you take care your system level ESD PCB design? Okay, how will you take care your ESD problems in the PCB? Okay, so you need to follow the guideline for ESD. So optimizing the impedance for dissipating the ESD. So one of the thing that you can see your ESD source is here and your protected IC is here and you are trying to connect your ESD diode somewhere else. So from source to your to here you have some inductance, some impedance, that is L1, and then from here this node to your ESD diode there will be also some impedance due to the lead, uh, the the component leads, and you can see from this node to protected IC you also have some impedance. So what is the basic idea is, so you have to minimize the impedances of L1 and L2. This is the basic things, and you have to place your protected IC as far as your ESD source. Place the TVS diode near to the connector as close to the connector as your design rules allow. Place the protected IC much further from the TVS than the TVS is to the connector. Do not use stub between TVS and the protected line. Route directly from ESD source to the TVS ground. Minimizing inductance from TVS and ground is critical. So let's say you have connector here and you are placing ESD diode here. You have to minimize the inductance of this path. Okay, and this should be as far away your source. Another system label ESD PCB design guidelines is limiting EMC, limiting ESD, EMC from ESD. So you can say like you have ESD source, you have protected IC here, and here you used, let's say, TVS diode or ESD diode. So you cannot route your unprotected line between these area. Because of that, it may impact your unprotected line. So you may follow this route. From here, you goes here and you can follow this route. So do not route unprotected circuit in area between ESD source and the TVS diode. Place the TVS diode as near to the connector as design route follows. Route with straight traces between ESD source and TVS if possible. In the corners, you must use the curve are preferred and a maximum of 45 degree. So you can see there is a three tracks is here, and one is you can see it's 90 degree and it can emit EMC. This is the 45 degree, it can nullify the EMC, and this is, if you are following this practice, this is the best practice, right? Another thing is limiting ESD. You can see, as I already spoke about connector ESD, this is the connector, and if you are routing your non-protected tracks between the ESD, there is a risk of coupling the EMCs, coupling the ESD issues to the adjacent track. This is another routing technique. You can see here, this is case 1, that is best case. This is case 2, that is worst case, and that is case 3. So in the case 1, they have source coming from here, then they connected ESD diode, and they connected one via and it goes to the protected IC. So this is the best technique. This is the worst technique. You're coming from here source, then through via you have given to this ESD diode, and you are going to the protected IC. So this will follow this route. Once you apply ESD here, this will come directly here. So ESD will not get clamped. This is case 3. This is not good practice, but you can follow this practice from source, go to the ESD diode, then via one wire and use one more wire to go to the protected IC. Avoid wire between ESD source and TVS diode if possible. If a via is required between ESD source and protected IC, route directly from ESD source and TVS before using via. So this is also another technique for ESD reduction. Multiple vias reduces the path inductance. So if you use multiple via on ESD diode on the ground side, it will reduces the path inductance, since it will come in the parallel. So guys, hope you have understood the basics of EMC. How will you take care the EMC issue in the early stage of your circuit design, and how will you take care your ESD issue in the layout design? If you have any further question, feel free to ask me in comment section. Thanks for watching this video.